Hi everyone and welcome to the Retro channel, and today, as voted by my Commander Keen patrons, we are taking a look at a Commodore 128D. Sadly, this doesn't belong to me, but I've been tasked to take a look, as apparently it is blowing fuses. So let's get it out of the box and check it out. Whoa. Need a bigger bench. Power cable, just your standard IC type. There is a very tired rubber band that's falling apart everywhere. And we've got the original foams, which are very loud and squeaky. Sorry about that. The keyboard and the slight yellowing. Pretty dirty, but it's to be expected. Foams be gone. All right, here it is. It's the metal case version, which I think was very common in North America, less so in Australia and Europe. So it's interesting. Yeah, the metal version was to comply with FCC standards, and I don't know, it's just metal. The plastic case version does have a spot for the keyboard, so it actually clicks in underneath when you're not using it, but this is the metal one. I think it does have a bit of internal difference compared to our regular 128, but there's only one way to find out. So I'm going to open it up first, just to see what is going on inside, rather than just applying power and crossing fingers. All right, so the big D. Looks like there's 2 screws on the back that need to come out. And looks like it's also missing a screw in the middle. I assume this just slides back. Alrighty, here we go. So yes, as expected, this is a slightly different board to the regular 128 boards. So normally you'd have a big Commodore print across the middle of the board there. And yeah, this power supply is different as well. I think the plastic case ones have a power supply sitting up the front here, but it is very clean inside. And there's some fuses included. That's nice. It should make life a little bit easier, although I'm sure I've got the right type around here somewhere, but at least I don't have to go searching for them. So at the moment, the fuse that's in there looks to be intact. There's actually 2 fuses. So there's one up here and there's one back here behind the transformer. Let's just see. All right, that one's blown. That one's intact. They are both 315 milliamp fuses. Seeing as we've got this power connector over here, let's just see if there's any shorts. So I'm guessing black is going to be ground. Yellow is probably 12 volts. That's me shorting to ground. There, okay. So it would appear that our red and black is shorted, which I guess, it does seem to be marked on the board. So red is +5, yellow is +12, and the brown and white are the AC. So brown and white AC should appear shorted, but that's just because it's going through the transformer, which is just a big bunch of wires wound tightly around each other. But yes, definitely red and black are shorted. So we've got a short on the 5-volt rail. Let's just unplug it from the board. Check that again. Oh, if I can get my probes in there. Yep, okay. So the short is on this power supply board itself. let's get this out. While we're here, before I forget, let's just see. Yeah, okay, that's not a short. It's actually 180 something ohms. So it doesn't appear that anything is shorted on the main board itself, which is a good sign. Hopefully nothing has actually been damaged from this power supply short. Let's remove some screws first. Figure it out as we go. It's a bit strange. Maybe that's just a bit of corrosion that's changed the color of... Oh yeah, that one's the same. Could be just from age. All right, I think the transformer needs to be released. All right, we are free. Let's remove this ground lug. Let's see if we can sort of flip this around. In fact, I probably don't even need to desolder it, but it's just going to be easy to work on if it's out of the machine. All right, so there's nothing visibly obvious from the top side of the board, but looking at the underside, there's definitely been some heat buildup in this area. Now, I dare say these caps will not be holding any charge. In fact, yeah, they're only 25 volt caps anyway, so it doesn't matter. Interesting. I'm just going to give this a bit of a scrub first, just so it's easier to see what we are dealing with. But I dare say it's just going to be one of these linear voltage regulators. Or is it a switch mode? It's got... maybe it's a switch mode supply. Anyway, I'm sure people are yelling at me who know more about power supplies. It's switch mode. Ta-da! Much better. Right, yeah, so there's definitely a bit of scorching on this spot here, which is this diode and these couple of resistors. Let's check that diode. So the diode is short that way and apparently short that way. Could be something else that has also shorted, but let's pull the diode out, or at least lift one of the legs, and we'll know for sure if that diode is bunged. Let's check it again. It's still short that way, and it's still short that way, so definitely an issue with that guy. So yeah, it looks like we're charging a capacitor that way, and it's still shorted that way, but that could be... what could that be? Yeah, there's a definite short going that direction, and we're charging a capacitor or something going the other direction. Let's just have a quick look at these two guys. That's charging a cap. That's performing like a diode. That's performing like a diode and charging a cap, maybe. That's charging a cap. Okay. We're not seeing any... Ooh. We are seeing a direct short there, by the looks of it. Yeah, so I would say this guy is also bad, and that might be where that might be why we're seeing a short across where the diode was. So pop this out too while we're here, and that is probably a better job for the desoldering gun. I don't think they've actually soldered these heat sinks to the board. They appear to just be twisted. No, they are not soldered down. That has us free. Actually, it doesn't say 7805, it just says D45H2. Let's check it again now that it's out of the board. Keep forgetting to bring the multimeter into shot. So that's reading open. I'm guessing that's our input to ground, and input to output is open, and our ground to output is shorted. I think that's our output. Either that or it's ground to input is shorted. Either way, we're not supposed to see a short between any of those pins. So that is definitely bad. So, bad regulator, bad diode. I don't think there's going to be any other issues. It may have stressed out these caps, so they might be worth looking at. In fact, let's take those out. And they have not marked the polarity on the board. I'm just going to do that just so I know. And test those. Anything else? I suppose we'll have a quick look at any of these diodes around the board. I better just test again. See how short from here has been removed, which is good. And what is that? Yeah, I still don't like the look of that. Oh, 47 ohms. Maybe that's just a drop of resistor or something just to soak up the voltage in the capacitors when the computer's turned off. I'm not 100% sure, but nothing too serious by the looks of it. In fact, I should have taken these other ones out too. Let's just have a look here. There's a couple more diodes hiding under here that we may as well test out to be sure, Okay, yep. They appear to be okay. They're at least not shorted anyway. This here... This guy here has no solder on it. In fact, that leg is free. This one here, which is this resistor, has a broken solder joint. It's broken on both sides, actually. I can see the other side is broken too. And the resistor next to it is missing solder from one of its legs. So I can understand the break with the solder joint because this is right where a lot of the heat was concentrated. So this solder joint would have been stressed and expanded and contracted and eventually broken. Doesn't excuse having absolutely no solder on that. That's quality control for you. Not sure if that's the company logo that made this. It looks like a cat. And there's PP. Maybe that means piss poor. Anyway, I'm going to work out what we need to replace these components, and then we'll stick it all back together and give it a test, I reckon. Alright, so looking at these parts, I can still get them, and I was sort of half right with this power supply. I did find the schematics, and it is a linear power supply for the 12-volt rail and a switching power supply for the 5-volt rail. So this is our switching controller IC as suspected, and up here that's our transistor, which is just a power transistor, and these are our two resistors here, just down here on the board. So with one of them not being connected, it's potentially overdriven the whole circuit over time. So it's not a big surprise that we had a failure eventually. And yeah, it looks like I'm going to have to order some parts. It's not too bad. It's maybe 10 bucks worth of parts here that we're going to need. The switching IC is like 80 cents or something, so I may as well replace that too. And hopefully everything else should work as expected, but I won't know until the parts arrive. All right, so our replacement parts have arrived. I did actually put out the first part of this video just to my patrons, just to give them something to watch. And one of them made a very good point in that these electrolytic capacitors wouldn't have seen that shorted supply because they're basically in parallel to the actual switching circuit. So they probably wouldn't have suffered any damage from the short circuit that was there. I will still replace them just because they're pretty old and they don't really give any specs on the body themselves about temperature rating or anything like that. So I imagine they're fairly cheap capacitors anyway. So we're going to use some decent quality 105 degree rated capacitors. These are all fairly long life, so they should be ideal for this power supply. The old ones are somewhat questionable anyway. So these are all our old parts. These are our new parts. Let's just throw them in. All right, so all our replacement components are in, including the ones that may not have need to have been replaced, but better to be safe than sorry. And we want this to last as long as possible. Let's just do a couple of quick tests just to make sure we're not seeing any weird short circuits. That's charging a cap. That's charging a cap. Actually, I might test these mains X and Y caps just to make sure. Oh, that's running through the turns on the transformer. So our caps are not filtered, but I mean, our caps are not shorted, but they're not reefers. So not those crystal package ones. So no chance of them getting moisture into them and splitting and then releasing the magic smoke. So I am pretty happy that we can safely plug this in. Let's do it. Right, our power supply is reinstalled and we've replaced all the bad components and some of the ones that were questionable. So with any luck, this thing should just work. Now I've already plugged it right into the motherboard, and I'm actually going to, while I think about it, remove that SID chip. Oh. Random. Just because we don't need that to power up. We also don't want to fry it. Although it may already be dead, who knows? Just going to borrow the power cable from the desoldering gun. And let's flip the switch. And the machine has sprung into life. That's a good sign. Let's have a look at some voltages here. So if we go, that is our negative. 12 volts, very nice. 5 volts, very good. And AC side of things, 9.4. Great. There is a buzzing. It sounds like it's coming from the power supply. I do not like a buzzing. Yes, there is a definite buzzing. I was thinking it was the transformer, but it seems to be making more of a hum. I think it's this little coil here. Yes, this coil is buzzing away, as is all these coils in here. Oops. And it's not a big deal, it's obviously working just fine. It's just kind of more of an annoyance. I guess it could be glued down to the board. Meh, what can you do? I'm sure with the cover on you probably wouldn't be able to hear it at all. Right, let's hook up a display and see if this machine actually works. Alright, keyboard's hooked up, video output is hooked up, just in the 40 column mode. Let's see what happens. Oh wow, that video output looks terrible. Like worse than a Commodore 128 would normally look. There are a bunch of lines quickly scrolling up the picture or down the picture. That looks like a voltage supply problem to the VIC-2, but maybe it's a marginal VIC-2 itself. It doesn't appear to be changing. Keyboard seems to work. Syntax error, that's what we'd expect to see. I don't actually have a way of testing the 80 column output, which is a bit annoying. Now those lines have slowed down. Yeah, I don't want to keep running it that way for too long because it does appear to be still something wrong. I guess I'm going to pull the power supply out and just do another quick look. See if I can spot something else. Even after checking it and swapping that IC back, everything, it still has some visible lines in the screen, and that usually points to the AC supply. So what I'm thinking, first of all, is just to check this filter capacitor here. After the AC gets rectified by this little bridge rectifier, it uses this cap just to smooth out the AC. Now it is currently in circuit, so this won't be completely accurate. 1025 mic, an ESR of 0.06, but a V loss of 40%. Now, alright, it is 1000 microfarad cap, so that's correct. The voltage loss could just be because it's in circuit, so let's pull it out of circuit. Lift one of its legs, if I can get to it. In fact, I may be able to do it from the top side. I won't force it though. Okay. Let's see what it looks like out of circuit. (900 microfarads), ESR still 0.06, V loss is 1.9, which is a little higher than I'd like to see. But the other figures certainly look about right. Do I have... I think I've got some of those axial caps. Yeah, okay. This is a brand new 1000 microfarad, 25 volt. Actually, ESR of 0, 966 and a V loss of 0.5. So that's definitely an improvement over what's in there. So I'm going to swap that out and see if that makes any difference at all to the video signal. Otherwise, we'll start suspecting it could even be just the VIC-2 itself is marginal. Right, well, it still doesn't look fantastic, but it looks a lot better, so I think that was the right choice. It could be something else that's marginal that's causing that interference, but yeah, like I said, the 128 video output usually looks terrible anyway, so go figure. Right, so I've done all kinds of tests with this power supply and I'm still just not happy with it. Moving this coil here causes it to make a different sort of pitched frequency, and it also affects the video output. And when I hooked it up to the diagnostic test, it also introduces a noise to the audio output, especially when we're using the noise channel on the SID. I even went as far as putting back the original components, except obviously for that diode and this transistor, and it actually made it worse. So these are still doing a better job, and I actually swapped out this 22 microfarad for a 220 because there is enough room on the board to accommodate a larger capacitor. Swapping that out made it a little bit better, but yeah, I'm just still not happy with what this thing is doing, and I don't know if it's just because this is, I guess, the cost reduced version, so I mean they, I guess, cost reduce the power supply as well. I don't know if it's standard behavior for a 128 DCR, but I'm not happy with it, so I'm going to move to plan B, and that pretty much is swapping out all of this DC component of the power supply for just a modern switch mode. Obviously I'll keep the transformer for the AC supply because that is still required to power the SID and also the VIC, or at least partially. And I think if it's the same as like a regular Commodore 64, it's also going to be powering the cassette port. So we still need that AC side of things, so the transformer is still required. But as for the DC side of things, yeah, I don't like what this thing is doing. I don't trust it to not eventually kill something else or kill itself. So I'm going to take some measurements of the current that is being drawn. I'm actually going to load this up a little bit so I can get a rough idea of the current draw. I'm going to put the Easy Flash cartridge in. I've got the keyboard connected. Just make sure that's working. Yes, it is. I'm also going to put in the 1541 test / demo disc, and we'll just run an alignment test with the drive, because that'll get the drive drawing power, the cartridge is drawing power. I mean, I don't have anything in the user port, but we can sort of aim for something above what's currently being drawn. And I'm going to remove this and just pull out the 5-volt line. And plug that back in, and we're just going to have 5-volt going through our meter, set to current measurement DC. Make sure that doesn't short to anything. So it's going to run through the meter and back into this plug, and that should tell us. Right, seeing about 2.3 amps. Just got to be careful to hold this plug properly, otherwise it'll lose connection and reset. Right, alignment check. Go. Right, so the drive itself doesn't seem to make any difference. It will make a difference to the 12-volt rail, because I think that's really all the 12-volt rail does. In saying that, this drive looks like it's still perfectly aligned. We're getting 100% with the on-track read, so that's always a good sign. just going to stop that and just power off. Okay, so 2.3 amps. So I think a power supply that I've got around here that would be suitable is rated for 3.2 amps, at least on the 5-volt rail. Let's check the 12 volts, which is this one. There we go. All right, bring this back in. Oops. Make sure we don't short to anything. All right, let's check the 12 volt side. Yeah, it seems to only go up when the disk drive is being accessed. Let's just do another alignment check. So it peaked at about 500 milliamps. And that was with, I guess, the spindle motor and the head motor, whatever you want to call it, words, stuff. In fact, a better test would have been head exerciser, F4 and F6. Yeah, I think I saw it peak at about 600 milliamps there. So 2.3 and 600. So I think the power supply I've got is rated at 3.2 amps for the 5 volt, and I think it's like 2 amps for the 12 volt. So plenty of room on the 12 volt side, and it should be plenty of room for the 5 volt as well. And that power supply is one of these guys. It's a Meanwell PD45A, the same power supply that I used recently when diagnosing a Commodore 1541. But this may become a permanent fixture. It's just going to be a matter of working out how it's going to fit if it does become a permanent thing. But I'm just going to disconnect everything, stick this in instead, and see if that fixes the problem that we're seeing. Right, so here's what we've got. I've removed the 2 diodes that sit on the output of the transformer and supply the DC voltage regulation circuit. So at the moment, we've simply got AC going through the transformer, and that basically makes its way straight through the fuse to the board. So nothing to worry about there. This is our power supply, which I have jankily hooked up to ground, 5 volts and 12 volts on the outputs. I've just soldered them to the other side because I don't have the right connector for that. And likewise, I don't have the right connector for the other side. So that's just connected to a figure 8 cable going to another power plug. Now, what I'm going to do is make sure this is already switched on. And I'm just going to plug this straight into the wall so that everything receives power at the same time. Power this on all at once and see what happens. There we go. We are powered up. The video output looks way better. Obviously, there's still those horrible jail bars, but that's just a common issue with the 128, so I'm not suspecting that as a fault. That looks quite good. Yeah, and the other thing I want to do is once again try the Easy Flash along with a disc, just to make sure everything still functions as it should. And then we'll just check the output from the SID as well, just to make sure there's no interference going through to there. Keyboard. Need a keyboard. right. Let's run the old alignment check. Yeah. Everything seems fine. Like I said, this power supply is more than capable of putting out the required current that's required to run this machine. I shouldn't have that solder sitting in there. That's bad. Cool. So just stop that. Obviously, the way this is set up at the moment isn't ideal at all. And I would need to work out a way to get this power supply to mount in this area and also be powered from the same output. But this is more just a test at this point, just to basically rule out any other issues. So this switching power supply and the linear power supply hybrid here is not great at all. All right, we've got sound. The time of day clocks are not working. I don't know why, but everything else appears to work just fine with this other power supply. Obviously, I need to find a way to hook up the power LED at the front of the case because that was going through the DC, so that shouldn't be very difficult to do. Yeah, I don't know what to do with this power supply. I guess I will contact John, who's the actual owner of this machine, and ask. Obviously, I'll pull the board out and actually solder this capacitor in properly. Also notice the can for the VIC is loose, like the entire thing moves around, so that needs to be redone. Apart from that, yeah, I'm just not sure about those time of day clocks. All right, so I spent a bit of time looking around, even broke out the oscilloscope just to check the input going to the timers, and then I finally realized that the fuse on the power supply had blown. That's probably just from me plugging it into the wall rather than using the actual switch on the power supply. So that's not a big deal, but at least I know that there is not a fault with the CIAs. And I did actually find the Commodore 128 diagnostics. So it's currently running through that. It does take a little bit longer because it has to test all the RAM banks, all 128K. So things are looking good. The image doesn't look too bad, really. I mean, for a 128, looks pretty good. So I think this is the best bet. Assuming that I can find a good way to mount that power supply in this area. So I'm going to leave all this here for now. If anyone has any ideas about how to fix the original power supply, or if you think I should just let it go, let me know in the comments. I'll also have to talk to the owner of this machine just to find out what they want to do. And there's still some little work to do off camera, like reattaching this VIC2 can and the VDC chip can. And I do have to rejig my diagnostic harness just so I can give everything a full test. The cassette port cable is very short on this one, and given the user port is over there and the cassette port is over here, I do need to lengthen that by just a little bit. So I'm going to do all that off camera. I think this video has probably gone on more than long enough, but we will come back to this machine, and I'm also going to do a comparison between the 128 DCR and the regular 128D because I have just acquired a 128D. It's a little bit rough, but we will be able to compare both of these units and see how they differ. Think of it like a buyer's guide for what, 30, 35 years ago. But yeah, until then, thank you very much for watching the Retro channel. Thanks to all the people who have subscribed and liked the videos. A massive thanks to my patrons, and I will catch you all in the next one. and hopefully we'll be able to do a bit of a closer look at the 128D and its variants. Thanks for watching the Retro Channel. Bye. Really should do something with my hair. Ugh. Power off.